Good morning to you. It's a beautiful morning. It's sunny outside and it's sunny in here, and I'm all by myself. So, I'm just going to make a short video here about your science lesson today, lesson 140, and also touch back on lesson 139 about sound. Sound is a lot of fun, and sound is what makes us able to hear. If there wasn't sound, we couldn't obviously hear anything. But first of all, did you know that the average household in the US, I didn't write that, but this is in the US, has 300,000 things in it. 300,000! It's a lot of things. But that doesn't have anything to do with sound. I just thought you might want to know that, because we can't do that anymore, so I thought I'd write it up and show you. 300,000 things. So we should probably start giving away some of our things, even if you think you don't have many. Sound. Back to our subject. How does sound work? What are sound waves? How fast does sound travel? What causes an echo, like you're going to be looking at today? And what is sound, most of all? Back in yesterday's lesson, you looked at what is sound. Sound is a vibration. Any vibration makes sound. For example, this blackboard vibrates. Hear that? Energy is required to produce sound. Notice how I have energy here. If I just stand here, I can't hear anything except the fish tank in the background and the furnace. Sound itself is energy. It moves things. Did you know sound can be used to drill holes in metal, on teeth, and it can also break up rocks? Did you know that? Sound can do that. Sound is powerful. So, in today's lesson, we want to understand how sound travels. First of all, let's look more at sound. So sound is vibration. Energy is required to produce sound. Sound itself is energy. It moves things. And then we have some facts about how fast sound travels. But how does sound travel? What are sound waves? You ever hear people talk about sound waves? Well, sound travels like waves. You ever go to the lake and see waves going up and down? That's a pretty good illustration. A better illustration is if you take a slinky and play with it. Sound travels by hitting molecules. Remember, there's molecules everywhere. Everything is made up of molecules, you learned in Unit 5. So sound travels by hitting molecules, and those molecules transmit the sound waves. The molecules don't move much. I'm going to show you. Here we have a Newton's cradle. You ever play with one of these? They're a lot of fun. So we have 1, 2, 3, 4, 5. I think they're metal balls here. And what I'm going to do is put this one, let's pretend they're molecules. And now this molecule is transmitting the sound to the other molecules, and watch what happens. Notice how it doesn't move the molecules much except the one at the other end. And the one at this end transmits the sound farther on. So sound uses molecules. If it's traveling through air, it'll use air molecules to travel through. So sound travels like waves through the molecules of things. I'm going to show you something else to demonstrate that. You can do this at home too. Okay, here we have some checkers. 1, 2, 3, 4, 5 checkers. Now I'm going to flick this one and it's going to hit these. Let's see what happens. Notice how these don't move much. Pretend these black ones are the sound. And these are the molecules, and it's transmitting the energy through the molecules. That's how sound travels. Do this at home if you have checkers. It's kind of neat. Oh, that was a poor aim. Let's try it again. Now that was a big lot of sound, but that's how that works. Isn't that neat? Okay, back to our board again. Another thing you should do today with this lesson is go outside. First of all, go to number 2 in your activities. Back of the lesson, number 2 activity. It tells you to get a board and a hammer and go 550 feet away from somebody. Or get somebody else to have the board and the hammer to hit it. And you go 550 feet about, so nice and far away from them. And then get them to hit the board and you watch. When they hit the board and when the sound gets to you, watch what happens. It's not going to be at the same time. I won't explain what happens, so you go and do it, but get somebody with a board and a hammer. If you want, you can come get this one, but you probably have one at home, and get someone to go far away and hit the board, and then see how fast sound travels. Sound travels through air at 1,200 kilometers per hour, 1,200 kilometers per hour. Sound travels through air, but through water, it travels a lot faster. It travels 5,300 kilometers per hour. And then if you go through something solid like steel, it'll travel 11,250 kilometers an hour. That's fast. If you're ever at a railroad track, put your ear up to the, make sure a train's not coming, but put your ear up to the metal track, and if a train is far off in the distance, you'll be able to hear it in the track far before you can hear it in the air. That's really neat. We don't really have train tracks around here, but if you ever have a chance, you should do that. See if a train's coming, so you don't get hit. Good. Echoes. Let's talk about echoes quickly before I stop this video. So what causes an echo? Do you ever go somewhere where there's a cliff and yell as loud as you can and see if you can hear yourself? You probably did. What makes that echo? Well, an echo is reflected sound waves from distant objects. It's simple. All it is sound waves moving away from the source until it hits something far away and bounces back. You can hear it. It doesn't bounce back as fast as it goes, but if it's a good object that I can hit against, it'll bounce back nice and clear. If you have let's say you have a big cliff about 100 feet away, you could probably even hear the words you are saying. So you could tell yourself a sentence and the cliff yells back at you. It's fun. Here I have a picture of supposed to be a loudspeaker, the sound waves coming out of it, hitting a wall and bouncing back. That's an echo. But for an echo to work, you have to be at least 30 feet away. So if you're within 30 feet, it's still going to bounce back, but you can't hear the echo because it bounces back too quick. It's happening at about the same time that you're making the noise. So for an echo, an object must be at least 30 feet away to produce an echo. So go find a cliff or something, maybe a sibling, no, don't do that, and yell at it, make loud noises, even if you do it against a hill, across a valley or something, and you should be able to hear your echo bounce back. Now if you're on somewhere flat and there's no objects in sight, you probably wouldn't get any echo at all. It has to bounce off something to come back. That's how sound waves work. They bounce off things. Good. So that's a brief touch-in with your science lesson today. Don't want to make it any longer. But if you remember, and if you have time, this would be a great thing to do outside. Do number 2 activity with the board and the hammer. And you can also do number 3 if you want. All you need is a yardstick and another person to help you. Tells you what to do. Thanks for watching.